All right, so I'm gonna try and be as straightforward as I can. I'm recording this video at pretty close to 1 in the morning. I'm pretty tired. I'm gonna yawn a few times in this video. Try not to let it distract you or make you sleepy, or just watch the video on double speed. It's not super important, but let's just go ahead and start with this. So we're gonna be talking about the intent attack surface today for the Android pen testing landscape. It's similar to the last few Android pen testing blog posts and videos in the fact that this is going to be heavily based off the hextree.io course. If you're looking for straight up solutions, they're not here, kind of with an asterisk, because you could very easily copy the code that I have on screen and get really close to having a working solution. For what, in my opinion, were, at least the first time I looked at them, fairly difficult challenges that were part of the intent attack surface app. So without any further, mucking about, let's go ahead and start talking about this. So before we can understand intents, we need to understand activities. This is, the documentation you can see kind of talks about as a single focus thing a user can do. I think it's better, maybe it's a worse way to think about it, but for me, I think about an activity as just a screen on an app. Most apps will contain multiple screens, so think of them as having multiple activities, right? When you make a new project in Android Studio, it'll by default do so with an empty views activity. And then there's that default main activity class that everyone starts with. So you'll see these activities declared in the Android manifest, right? So you can see this main activities exported, and it being exported is kind of important. And then you can see the intent filter, which we'll talk about in more detail here in a second. But the main thing about that being exported that's important is the fact that an app being exported means, or when exported is set to true, that means that any app can access this activity and launch it by its exact class name. So, if you have an application that, for whatever reason pulls up sensitive information or something like that, it wouldn't be wise to have it sitting there as an exported activity, because any malicious app could just open that and, that could cause some issues for the user, especially if it's a privacy thing, that kind of thing. But you might be asking, well, who cares? How do we actually interact with these things? Well, attackers can provide inputs to these activities by using intents. So an intent is described in the documentation as a messaging object that you can use to request an action from another app component, which is totally not confusing at all. I've heard some people describe intents as just data, and I don't think that's a bad example. It's basically just how, data, or I guess maybe intent is a better way to describe it, but here's how I'll explain it. Your app is declaring to the operating system that it wants to perform some kind of action, and then the operating system, for Android in this case, is performing that action. We can actually practice a pretty straightforward example by just spinning up a little app with two activities. So we have a main activity and a second activity, where the second activity is non-exported. So it can't be called by just any activity or any app. So we have a button here that should open the second activity, and then programmatically, after I show you both these XML files, programmatically, we can just use an intent to call this, right? So you can see here, on create, so this is for the main activity. Whenever we click this button, we have the on-click listener set for it. When we click this button, it creates a new intent that will that's launched or created in the context of the main activity, and it will call the second activity. So you can see when we click the button, it opens the second activity because we start the activity when the button is clicked. The rest of this code is boilerplate. It comes with it, like super edge to edge, set content view, and then this view compat, that all comes with the empty view activity. So you don't have to worry about that code really at all. And that functionality is pretty straightforward. But notice here, we are calling this from the perspective of the inside of the application. There's two different ways we can call this. If we were calling this from another application, we would need to call second activity like this, but that would only be if it's exported. So you'd have to specify the context. So this is the application activities test. And then you'd have to specify the actual name of the activity here if you're not a part of the same app. In my example, you could just use this because we are in the same app, but as you'll see later on, we're going to be calling intents that belong to other applications. Another question you might be asking is really like, what can call this activity? It depends on if something is exported. So in this case, second activity is not exported. So only our app, only, I should clarify, only apps that are or activities that are part of the same application should be able to call a non-exported activity, if that makes sense. So the next example we're going to look at, because I think calling basic exported activities is kind of a stupid example. Not stupid, but it's not getting us the most out of our time. And I'm trying to go through this pretty quick here before I fall asleep. So let's talk about how you might call an intent with an extra. This is, again, all of these flag something activities. These are from the IO, and it says at the top right here, IO Hextree attack surface application. You can download this using the Hextree course that's free online. I'll have it in the description, same as the last couple videos. But basically all you got to do is this application is ready to receive an intent. You can see here it writes this, action for the intent to a string. And then it checks to see if that action says give flag. And if it does, it calls success, and calling success in these will print out the flag. So solution's pretty straightforward. You just, in your main function, set it so that whenever you click the button, creates a new intent, calls IO Hextree attack surface context, calls the flag2 activity, and then you can set the action for your intent that you just created so that it says give flag. And then you start the activity, boom, solves the challenge, nice and easy. This one is basically just an add-on for the last one, which is just adding an additional piece of data to it, in this case a URI. So again, create an intent, specify the context and the activity you want to call, in this case flag3, set the action, and then set the data. In this case, it wants us to use this this specific link. All you have to do is add that link and then send the activity. Again, really straightforward, not super complicated, pretty solid example. The next one is where it starts to get tricky, which is calling intents that are nested inside of other intents. So in this case here, you can see that, let's see, it gets the incoming intent, and we need to make, we need to make an intent that includes this Android intent, extra intent. What do you call it? Extra. And you can see that this gets packaged seemingly inside of intent 3. So intent 3 contains intent 2, calling it next intent. And then intent 3 has reason, which when set to back, we'll call success this. So how can we, let's see. I think if I go to our code, that'll explain it a little better. The steps are kind of backwards here, but we create an intent here that's calling flag5 activity, which is the activity that we're using in this example. And first we just make an intent that has this intent extra assigned to it, and it's got intent 2 inside of it, because that's what this wants, right? First one needs to be this extra intent, and it needs to have intent 2 coming with it. Intent 2, the name isn't important, it's more the contents of it. So intent 2 is the fact that it has return set equal to 42. So we set that right up here. We create intent 2, set return equal to 42. And then we include this third intent with reason back inside of intent number 2. So that when this gets sent, intent 2, it has this, so it checks the box. It has this, so it checks that box. Intent 3 has this next intent parseable extra inside of it, and it includes intent 3. And then because the reason is set to back, it goes into this loop and gets us success at this. Should make a decent amount of sense. The comments are kind of bad on this piece of code, and it's also out of order. Those are both things I totally could have fixed, but chose not to. Now, those are all just examples on how you might interact with intents, but there's some common intent vulnerability types that we could talk about. One of them is going to be intent redirect. This is also sometimes called intent forwarding. And this is where an attacker can control an intent that's used by another app And something to keep in mind here, right? If you have two apps, so let's say like app 1 and app 2, let's say social media and malicious app, right? If social media has an exported intent and malicious app hijacks that intent or redirects, I should say, redirects that intent, even though malicious app is sending an intent to social media app and then it sends another intent somewhere else, that's being executed with the level of privilege of the social media app, right? Because it's coming from there. And we'll see that really just in our next example here for flag 6. So you can see that flag 6 is not exported. So we can't just call this like we did for the last one. We're actually going to have to utilize some of the flag 5 solutions. So back here in flag 5, you can see we set our reason to next instead of back. The next intent that we include, in this case, I'm pretty sure that's just what intent 3 would have been. Yeah, let me see. Yeah, so basically, if we set reason to next, our next intent will be passed through the start activity. And so it'll be started with the permissions of flag 5 activity, which is the same as the app. So this could call flag 6 activity, and flag 6 activity just needs us to have this tag. So you might see where we're going. We just edit the last code. And sorry, I realized in hindsight that I have 2 step 5s in here, but not a big deal. Same thing, right? We create an intent. Inside that intent, we have this extra. We also have intent 2. This is pointed towards flag 5. Intent 2 has returned 42, same as last time. Intent 3 has this, or now intent 3 is where we actually start changing things. Or intent 2 still has next intent with intent 3 inside of it. Intent 3 is specifically for flag 6. Reason is set to next so that it goes down to this chain here, gets passed into start activity. And because it's getting passed into start activity, this intent 3 will then be forwarded because it's with next intent. It will then be forwarded with this flag set, and that should get us this flag when we call it. So same thing, you just map this to an on click, press the button, and it should work fine from there. It basically goes into flag 5, and then we redirect that intent to point towards flag 6, which we should not be able to control a call to. Hijacking implicit intents is somewhat similar, but it's a little bit more, I don't know, it's a little bit similar. So let's just talk about it. There's an intent here, and we're explicitly calling this intent using the package name and the context and the activity name. Here is an implicit intent. So obviously explicit is harder to take advantage of because this is hard coded, right? But this image capture, action can be set for an intent, and any application can set these however they want in their intent filter, just like this. So let's say you're on social media app and you want it to take a picture with your camera. It would then, the Android operating system then determines which applications can handle this image capture action by looking in the intent filter, and then it would give you a list of options. So it'll show you, is that on my next slide? No, I don't think so. But it'll then give you a list of options of which types of apps can handle that kind of intent. So we'll walk through this example here for flag, what's this, 11? So these ones are a little bit different in the sense that you need to click on these and then they send an implicit intent out to your application. So in this case, you can see that it creates a new intent with this attack me implicit. It makes an implicit intent like this. So you need to export your activity to have this attack me thing, and your intent should be exported. And then it's looking for basically this token parameter, and it also wants the result for the intent to be 42. So as long as you have this token tag or this token extra that's equal to this number, that should fulfill all the conditions. So you have your second activity with, again, you want this in your intent filter, this attack me thing in your intent filter for the second activity. So that when you click the button, it calls our second activity, and then on create, which is just when second activity is called, it creates this intent, adds the token in the value, sets the result 42, and adds it to this result intent, and then it finishes. And by finishing, it just sends that, what's the word I'm looking for? It replies with this information whenever it's called. So that's one thing to think about. On the topic of replying, though, pending intents are where it gets tricky, in my opinion. So a pending intent is an intent that lets one app create like a start activity intent, and then give that intent to another app to perform some activity with the original app's level of privilege. So in our previous example, like if social media app and malicious app, if we were doing intent redirection, malicious app sends something to social media app, and social media app executes another activity in itself with its own level of privilege. A pending intent, if we sent a pending intent to social media app, it would have the malicious app's level of privilege, which wouldn't be able to call that internal activity, and it wouldn't be an issue. The issue with this, though, is you might think like, oh, well, doesn't that make pending intents like kind of a mitigation to intent redirects? And the answer is yes, but it just kind of changes how you'd have to exploit it. So if you have social media app over here, malicious app over here, social media app might send a pending intent somewhere, maybe in an implicit intent to our malicious application. And then if we can control this intent, like if it's mutable, which just means we can mess with it, then the issue is we can now perform some kind of action in the form of an intent using the privileges of this app that's sending the pending intent to us without discerning who it's being sent to. So an example of that, we can first just go over how an app might or how you could receive a pending intent. So this in the course is after the utils class is discussed, but basically, this activity flag 22 is exported, so we can call this from our application, and this should just show an example. So this program is set up to see if the intent that was used to start this activity had the pending extra set here. So once this happens, the program will then create this new intent, and it will include the flag as an extra to this intent and then send it back. So you need to have this like utils class ready for it. I don't know if utils is called in here, but I'm basically handling it like this. So I just send an intent to flag 22 with this pending extra attached to it, and then put this pending intent inside. I also make it mutable so that this can be changed once the application receives it. So we send this pending intent to the application, and then it will reply with the flag in like your debug menu. If you're following the course, this will all make sense. If you're not, I might be kind of, not being as specific as I could be, but I don't want to give away like all of the solving it, because that would ruin a lot of the fun for anybody who's trying to follow along the course and just wants a pointer. If you're hijacking a pending intent, it's a little bit more complicated. I actually got stuck on this challenge for like a day and a half. It was really frustrating because I just didn't know what I was doing. And then I went through it again, and it made a lot more sense when I actually read it carefully. So, it's kind of similar to the last code, but there's a few more things. So, this code gets our intent. I think, where is it? Right here. So gets this action for our intent and writes it to this string. And then you can see here a new intent, in this case intent 2, is created, and it has this give flag action set, or this give flag, what do you call it, set. Then this pending intent called activity is created that includes intent 2, and it has this long string of numbers. This is the constant value for saying that you have a flag mutable. This means that because this activity pending intent, or I should say the pending intent called activity, has intent number 2 in it, but it has the mutable flag, so we should be able to change properties and things that are inside of intent2 without messing with it. And the application should be willing to reply to it. The next thing that we can look at is intent3 is created with this mutate me. What do you call it? This mutate me action set. And then this pending intent is added as an extra to intent number 3. So intent number 3, imagine big circle, has a pending intent inside of it with intent number 2 inside of it. And all we need to do is basically bounce back intent number 2, right? Because it has this give flag thing and it's mutable, so we can bounce it back. We can reply with it. And just make sure that it has this extra called code that's equal to 42, and then it should call success for us. So first, in order to do that, let me try and break it down a little bit faster. So we grab the intent, or in our application, we need to grab the intent that starts our activity, take it apart into the intent3 pending activity and intent2. And then we need to configure it so that it fits those needs and then send it back. We also need to have our second activity exported, or at least in my case, we're using the second activity exported. And I'm using mutate me in the intent filter so that when we click on the flag 23 activity button inside the attack surface app, it sends this pending intent looking for this mutate me implicit, like looking for this implicit intent type. So you click the button, Android operating system says, who can handle this mutate me thing? Oh, this can handle this mutate me intent filter. We'll use that. So here's what our solution code looks like. We first create this, we capture intent3 as it comes in. We extract the action from it, not unlike flag 22 did. Assuming mutate me is the action, we go into this, we start taking it apart. So we first extract like this pending intent out of intent number 3. Then we take intent 2 and just add the extra code 42 to it. And keep in mind, this only works because this is mutable. And it doesn't take away this, where is it? It doesn't take away this give flag attribute, because even though it's mutable, it's not like we're overwriting that specific action. We're just adding this extra code that's equal to 42. Then we just make it so that, upon the second activity being called, it will reply by sending the pending intent 2. So when calling that, sends it back. Intent 2 still has give flag, but now it also has code equal to 42, and it passes this check, and then we get the flag. That was a little more complicated. Now we're going to get onto something a little bit easier to understand, and this branches away from the malicious app threat model and is more towards the victim user clicking a link. So a deep link is a URI of any scheme that can take users directly to a specific part of your app. And you would make you could do this like this. A good example of this is like, let's say you're on a mobile device and you're searching for like an address. You click on that address and it opens up, Google Maps or Apple Maps or Waze or something like that. I don't know. Those deep links can open an app directly because the application is set to handle this specific kind of URL. In this case, you can see like the scheme. So instead of HTTP : // it'd be like geo : // You also need to have your intent filter where you have, I believe, browsable is the important one here. Default and view, I'm not totally sure, but I know that browsable is important for this. You might be asking why deep links are included in this blog post about intents. And that's because if we look at this example here, right, the scheme is X, the host is open, and we create that link and click on it, our debug menu says that this was an intent with the action view and it was in the browsable category. So this is still kind of acting just like an intent, right? It's sending data to an application in our app that's exported in some way. So like you can see here, this flag activity is exported. And so when we click the link, because it's exported, the browser can execute it. It's just the fact that you're executing this deep link, or it's just the fact that you're calling an intent by having the user click a link instead of having them download your malicious app and you having to, get that functionality triggered some other way. And it shouldn't be surprising that the data, sent as an intent. And I don't think we look at the code by much more in here, but you can actually see how this could be like manipulated, because YouTube uses deep links, and in the Hextree course, they use an example where you can basically make your app, in my case, activities test, impersonate another app by copying the intent filter, change the display name of your application, and you could trick a lot of people into clicking on your app if it's already installed on their device. But that's really all I want to cover for deep links, just because we will definitely touch on it again at a later date. I think the last thing here is the ending note, and then we'll go through the demo. So really, just don't use deep links or intents for sensitive data like login flows. And if you absolutely have to use deep links or intents, make sure that you're using explicit intents and explicit deep links. So there's an explicit deep link that I didn't cover, but Google Chrome uses it, and it lets you specify a lot more details. So you can specify the package, action, category, and component of your deep link. So just make sure that you're using explicit intents and explicit deep links instead of the implicit ones, so that they're a little bit harder to manipulate and mess with. You can also use app links that let you verify the calling app and the website. So like if your app is designed to handle a deep link, you can make sure that that deep link should only be from a certain website or a certain app, for example. So, if, for example, I can't think of a good one, but you might only want like the Google Maps API to be able to open the Google Maps app or something like that. So maybe those links should only be coming from like the Google Maps domain name or something. That's an example. For our demo, I made a quick little CTF application where we are just going to put on some music, and you guys can kind of watch the process of understanding and solving that challenge that I made. I'll have a link to my GitHub so you guys can download it if you want and play with it, but you could totally just find the flag in there. It's not complicated. But I'll put on some music, show how you'd go through and exploit a really straightforward and simple intent redirection vulnerability. All right, here we are with the demo portion of the intent attack surface. In order to follow along with this, I'll include a link to my GitHub repository that has the APK that we're going to be messing with. In this case, pretty sure it's this. Yeah. So we're just going to practice an intent redirection because this is what I could whip up quick enough to make it a decent demo, and a lot of the CTFs that I could find that kind of implemented this stuff had a few other things that kind of went over my head, and I didn't want to misrepresent something that I didn't totally understand. So we're just going to walk through figuring out what this application does, which is really simple, and then creating a short little exploit code to get us the flag. So obviously, right, we're clicking around. We can't do anything here. So that's about all that we've got to do with this application. If we take it apart in JADX, we can look at the Android manifest, and we can see first that it's what is this? COM example, CTF example. We can see all these different activities. The main activity is exported, vulnerable activity is exported, and flag activity is not exported. We can look at each of these. The main activity, as we kind of saw, right, all it does is set the view for this onCreate method. So when we start the app, all it does is set the view, which is what we just saw. We can look at vulnerable activity, and you can see that it's set to handle an incoming intent that has this extra. And then assuming that intent that's coming in here has this extra, it will then pass whatever this intent object is, or whatever the intent is, to the start activity function, which we know from our previous examples is not the best thing to do. And then it calls finish, so it just executes that. So one more thing we can look at is the flag activity, which would be, the sensitive whatever placeholder, sensitive functionality we want to call, and it's not exported, so you can't just call this directly. But if we look here, all that happens here is when this is launched, it sets the content view so you can see the flag, and then grabs the flag from the flag utils class that's present here. if you're following along, feel free to reverse engineer the flag utils. It's not super complicated. You could definitely get the flag from it, but just be mindful of the fact that there's, a pretty straightforward intended solution. So, and it's not like you'll get anything for getting the flag anyway. So that being said, we should be able to just create a vulnerable app for this this is just a views activity with a button present. It's pretty straightforward. We don't have any exported activities. This is just the main class, and this is just to be a good example for what we want to go over. So first, we need to make an intent, right? And this intent just needs to be pointed towards it needs to be in the context of the app that we want. So, and we can do set component, new component name, put that there preemptively. And it was com.example.ctf_example. We'll copy this. And then we need to specify the activity, which is the vulnerable activity. Once we're at that point, let me do then we'll set it so that whenever we press the button, so for this on-click view, it will start the activity. Let me minimize, or actually, yeah, we'll just minimize that for a second. We'll go ahead and launch our app. And you can see here's the main activity. Here's the button that we can use to send this intent. And all this should do is open the vulnerable activity, right? That's all it should be doing. Makes perfect sense. That's its function. So now what we can do is kind of hone in on this specific extra that needs to be included. So to do this, we need to first understand that this intent that we're making and calling, this isn't the intent that's like being how do I describe it? This isn't the same intent that's starting the activity. It's whatever this following intent is going to be. So we can make another intent. And we can basically just copy this, except point it towards the flag activity. And then all we should need to do is put that extra that it needs. So we can attach that extra to intent 1 that's being put in. Intent 1. And we can attach that to intent 2. And then when we run this, it should get the flag. There's an intentional spelling error here for extra intent, as you can see that even though this second intent is being sent, it's not like there's any functionality. So it's still just going to leave us here at the vulnerable activity. And because we don't meet that condition that's in the vulnerable activity here, right, it's not going to work. And I think also if we attach this to intent 1, it also shouldn't work because it's not going to the right place. So I'll show you what that looks like as well. Is it started? Let's see. We build it again. That time it just straight up crashed, it looks like. Yeah, okay. So, but again, if we attach this to intent 2, run this, and we get our flag. Straight and simple. And the only reason that this is a really something you could consider to be intent redirection is because we're sending our intent from our malicious application in here, and because this vulnerable activity handles our intent in an unsafe way, passing it directly into the start activity here, we can then call these other activities that are not exported, so that we shouldn't be able to call from that from the perspective and with the privileges of this target application. So the way you could fix this kind of problem is first just not having it so that it handles incoming intents like this. You might have some functionality that you want to handle incoming intents, but if so, don't just pass it in without any of this. Or if it's coming from certain applications, you can make it so that any intents coming from different applications have to set it explicitly, so that you're ready to handle only certain things. But that's all we have for the demo for this. Again, pretty straightforward, not meant to be super complicated. I would highly recommend going through the Intent Attack Surface app that's a part of the Hextree.io course, because it will have you cover way more than I talked about in this video. And I'm pretty sure by just following through with the not even, yeah, this is just for the intent attack surface module. You'll go through a ton of these different flags here, these two being my favorites. So I highly recommend going through Hextree.io and taking a look at that course. But that's all we have for now. So I'll catch you next time with whatever we're talking about.